Welcome to this session on trust in digital technologies. I'm Ari Lampinen and I will be hosting this session today. And what will happen now is that we're going to be hearing 3 short talks from different projects. And after that, there will be plenty of time for questions and conversations.
Hi, and welcome to the presentation of our project on resilient decentralized computing. My name is Philip Haller, and this is a collaboration with Paris Carbone. Processing personal information is a big issue in widely used systems such as social networks. Unfortunately, we regularly see incidents where personal user data is shared in ways that are not permitted according to privacy rights and regulations. The main issue is that current software systems are not designed with privacy concerns in mind. The resulting problems are both legal, where users' rights might be violated, and technical, since it's very difficult and expensive to change systems to comply with data privacy regulations. The technical challenges are immense because most modern systems are distributed, which means that user data is typically scattered across multiple systems. This means that it is extremely hard to enforce data privacy rights in modern systems. Within our project, we are building a programming system that is able to provide a set of properties that increase both trust and resilience. In previous work, we've investigated fault tolerance, data consistency, and static checking. And in this project, we build on this foundation, and we're investigating new ways in which decentralized programming systems can guarantee properties such as privacy-preserving computation by construction. Concretely, we propose a new user-friendly decentralized programming framework that automates resilience and data consistency for decentralized apps. So apps that run on mobile devices, IoT devices, vehicles, and so on. The framework will also enable defining data access policies in a declarative way, enabling privacy-preserving applications. This way, our approach aims to enable trust and resilience by design. In our approach, the compiler checks the code of a decentralized app for data consistency violations and also ensures resilience. The application logic is represented as so-called pods, which enable quite flexible application architectures. In particular, pods can migrate and serve live software updates or machine learning models, for example. Pods enable offline computation, and they also enforce data access policies, enabling privacy-preserving applications. In our current approach, we investigate the case of separating application logic and state within our pods framework. The separation itself shows great potential for supporting properties such as GDPR compliance, since first, applications do not need to be aware of the user requests related to their share of the state and can simply read and write data and send messages as long as they have access to it. Whereas requests such as deleting user data or revocations can be applied independently through the state abstraction in the pods design. Of course, this can be extended to support other properties beyond GDPR compliance. To conclude, increasing trust in next-generation software systems requires a principled approach to privacy and resilience. In our project, we leverage the synergy between programming systems on one hand and distributed data management on the other hand. An initial result is the design of a novel programming abstraction called pods, which we hope will simplify building resilient, privacy-preserving systems and applications. Thank you very much for your attention.
So hello, my name is Madeline Balaam, and along with Ari Lampinen, we will be presenting the Research Pairs project, Layering Trust in Intimate Digital Health Technologies. In this project, we're particularly interested in how trust is distributed around a social context in relation to an intimate health technology. We think that AI systems are poised to really disrupt the ways in which we deliver and experience healthcare. And because of this, trust is a key issue that really must be understood and designed for to make these kinds of innovations work. One example of a AI technology that's already disrupting intimate care is Natural Cycles. Natural Cycles is a Stockholm-based company, and we think it could be categorized really as an explainable AI system that provides an algorithmic contraceptive option to more than 700,000 users worldwide. We think about it as an algorithmic contraception since Natural Cycles uses daily readings of a user's temperature, an algorithm and machine learning to develop a model of a user's reproductive cycle. This then allows a smartphone application to detect periods of ovulation and thus predict when somebody is fertile. It can then recommend to the user that they use a barrier form of contraception if they wish to avoid becoming pregnant. So the aims of this study is to really explore people's experiences of using Natural Cycles in order to understand, in particular, how trust is distributed across an intimate relationship and perhaps essential other individuals in making the work of this algorithmic contraception happen. We also want to work with people who use Natural Cycles and those alongside them to design different types of interactions with a product like Natural Cycles that would allow for trust to be better distributed between the people who are involved in using the application. And finally, we're hoping to initiate a conversation with society about how algorithms affect our experience of life, and in particular, how when they are designed in particular ways, they make concrete existing biases within society. We're using this money in a number of different ways to fund a PhD student and to support the employment of a postdoc. We're currently waiting for ethical approval in order to begin our interview studies and workshop. But right now we're involved in a collaboration with Professor Marinella Chiolfi-Felice, who is utilizing a topic modeling approach to analyze thousands of reviews left by people who have used Natural Cycles on Google Play.
And to give you more of a sense of the research focus we're taking in this project, I wanted to say a few words about the social context of use as our focus of study. So if we think of studies on trust and technology, traditionally the focus is often on the main user of the technology, but when we think about who needs to trust Natural Cycles, it becomes quickly quite apparent that there are more people involved in this use situation than just the main user of the system. So we are really interested in interpersonal trust, and especially the kinds of negotiations and the kind of effort that goes on between partners as they are using Natural Cycles as a form of contraception. And secondly, also the organizational aspects of trust that may come up in context of Natural Cycles use. So when people encounter healthcare professionals, self-tracking tools may come up, and those encounters can be contentious in different ways. And to give you some examples from my early work on the review data, we wanted to just show how trust and teamwork come up in reviews of Natural Cycles. So here we have one user who describes her experience as the following. I have been using Natural Cycles to prevent pregnancy for 2 years now. I love how interactive it is on terms of keeping your partner in the loop too. Teamwork all the way, and I look forward to using it to plan pregnancy someday. And another person writes in this way. I've been using this app for 5 months now, and I love it. I had issues with the pill, but this allows me to track really precisely my cycle and has completely replaced my previous contraceptive methods. It also helps share the burden of contraception with your partner, as they can track your fertility with you and better understand what it means. We love it. But of course, as is so often the case with technology, it is not always quite so straightforward. So here are a few more examples of the kinds of things that come up when we consider intimate health technology in a social context. One problem, it is hard to take your temperature the way they suggest when you have small children. More mornings than not, I am summoned out of bed within an hour or two of waking time to tend to a child, thereby losing my basal temp. It also would, I imagine, not work if I still had babies which were waking several times a night. Also, my husband doesn't trust it. He thinks it's sorcery. And another user writes like this: as someone already in touch with my cycle, I found this app still really useful to confirm my intuition and feelings about my cycle. Also great for making it real to my partner, which indicates how this might be something where the technology can also support relationships. To conclude, what we're aiming to do with this project then is to really go beyond the individual in studying intimate digital health technology use, and also as we go forward, go beyond understanding the use of these technologies to also thinking of how we might better design to support these multiple layers of trust that are relevant in these situations. Thank you.
Hello and welcome to my presentation on this project called Threat Models for Cyber Insurance. My name is Robert Lagerström. I'm an associate professor at the KTH, Royal Institute of Technology in Stockholm. In the team for this project, I also have Ulrik Franke, who's a senior researcher at RISE, and our newly hired postdoc, Carlos Barreto from Colombia. Let me first just remind you about the problem. We're talking about digitalizing in Stockholm, and our project is funded by Digital Futures. But this digitalization of society, it has a lot of benefits, of course. That's why we do it, and I don't think there's any stop to it. But what we also see is an increased attack surface, which can lead to, well, more advanced cyber attacks, more cyber attacks, and so on. We read about this almost daily in the news. Now, for instance, during COVID, there were quite a lot of hospitals around the world who were hit by ransomware attacks. So one of the issues here is that IT, so basically our software and our hardware, it's very complex. So even a simple software like a web browser contains millions of lines of code, and as you see in the bottom left figure, the matrix, that's a representation of a web browser, and it contains more than 60,000 software files, all dependent on each other. And this kind of complexity, studies have shown that this increases the likelihood of vulnerabilities being introduced, vulnerabilities that can be used in cyber attacks. To the bottom right, we see a similar representation, but on an enterprise level. So a company today, they don't have just one software, they have thousands of software, and then they have hardware and processes and networks and people and all kinds of things, making it very difficult to predict where can an attack start, where can an attacker go, what kind of impact will a cyber attack have on our organization. One of the suggested solutions to this is to use threat models, and with these threat models run attack simulations. So basically a threat model is a representation, a map of an IT environment. With this model, what we have done in our research in the past is to couple it with attack graphs. So to be able to reason and run simulations on how an attack can traverse the IT infrastructure. And with this, then find suitable metrics to be able to handle these attacks, these risks in a good way. Now in this project, we will focus on cyber insurance. Previously, we have looked at using threat models and attack simulations for certain domains like vehicles and power systems and cloud infrastructure. But here it is to see if these can provide better decision support for cyber insurance. So one of the things is to use it to be able to offer more precise and quantifiable assessments of risks, which can then entail more precise pricing of existing products, which is good for both the customers and the cyber insurers. This approach, we believe, can also offer more precise and quantifiable assessment of risk-reducing measures. So what to do, basically, to prevent, to be more resilient. And thirdly, we believe that this can offer new qualitative insights into unknown risks. So this would enable insurance coverage to be extended to previously uninsurable industries. Yes, thank you very much. Looking forward to your questions.
Thank you for listening to the talks. It's now time for questions and conversation.